Hello. Hello.
Hello.
Yeah. Can you hear me?
Yeah,
Okay. Did you go through this chapter 15? We had discussed a few parts of it in the beginning.
I went all the way to chapter 15.3.
Okay. Uh, the first couple of sections, did you do the exercises there?
Yeah.
Is there any problem?
No.
So how do you do, for example, 15.1.5?
15, oh, 1 sec. 15.1.5. So what I did for that question, okay. So I did that x squared minus 6x plus k minus 17 is greater than 0. And then I kind of like completed the square for it to get 36 minus 4 times k minus 17 is greater than, sorry, like I kind of made it into like a quadratic, to solve it for the b, to see the discriminant. So then you get 36 minus 4 times k minus 17. So then the discriminant is 104 minus 4k. And since
The discriminant should be greater than 0 or less than 0 for this.
less than 0, less than 0.
So you get 36 minus 4k plus 68. Get 36 plus 68. So 106.
Yeah.
You should get k is greater than 53 by 2.
Oh wait, isn't it 104?
Or yeah.
Yeah.
So k is greater than 26.
Yeah, I got that.
Okay. For k greater than 26, what will happen is the quadratic will not have any real roots.
Hmm.
So that means then it will always be above, right?
Yeah.
In the second section, we had seen some questions for that. Like, have you tried the 4 questions in the exercise for second section?
Yes.
Okay, so how do you do, for example, 15.2.2?
Oh, 1 second. The second section. Okay. 15.2.2.
Right. R minus 3 whole square multiplied by
Oh yeah.
4r square minus 25 is greater than 0.
So what I did, I like simplified it to get r minus 3 times r minus 3 times 2r minus 5 times 2r plus 5. And then I just did the wavy curve method from there.
So you don't have to do this part. This you can ignore actually. Why? Because r minus 3 whole square will always be positive.
Yeah.
So since you already always you know the sign of this, you don't have to include it in wavy curve. Right?
Oh yeah.
You can just do wavy curve on this much because whether the sign of this is positive or negative will decide what the sign of the whole thing is, right?
Yeah.
So just on wavy curve on these two, you'll have to write minus 5 by 2 and 5 by 2, right?
Mm-hmm.
So when is it positive? When is it negative?
Oh, it's positive when it's less than 5 by negative 5 by 2 and greater than 5 by 2.
So when r is greater than 5 by 2 or r is less than minus 5 by 2. In both the cases, the product of these two is positive. And anyway, this is always positive except for 3, right?
Yeah.
Except at r is equal to 3. Because what will happen at r is equal to 3?
It'll equal 0.
But 0 is not going to be a solution, right? You have to be
Yeah.
greater than 0. So what we'll say is this is correct, but we have to subtract 3 from it, right?
Yeah.
So if you see the number line r is greater than 5 by 2 is this part and 3 is somewhere here. So you have to exclude that,
Yep.
right?
Yeah.
R is less than 5 by 2 minus 5 by 2, there is no issue. But here you have to exclude 3. That will be your answer.
Mm-hmm.
15.2.4.
15.2.4. Okay, so for that question, since it had the same denominator, I just multiplied the entire thing by that to get x plus 3 plus 1 over x plus 3 is greater than or equal to 2.
That is a
And
mistake.
then,
That is a mistake because that's what I discussed. No, you cannot multiply unless you know the sign. You understand? I specifically said this.
no, but if it has the same denominator, wouldn't that mean the top has to be like greater than or equal to because it'll have the
No.
same sign on the bottom?
Like, do you know already the sign of the denominator? Do you know the sign of the denominator, right?
No.
So how can you multiply without changing the inequality?
Oh, okay. I see.
If the bottom was negative, do you think we can multiply by negative quantity and not change the inequality sign to less than equal to?
No.
The problem is that the bottom thing has unknown sign. We don't know whether it is positive or negative, right?
Yeah.
Because x can be anywhere. We don't know yet whether it is positive or negative.
Uh-huh.
So you can never, in any inequality, you should never multiply by something which has unknown sign.
Okay.
If you multiply, it looks easier, but you're missing out on the situations where this part is negative.
Oh,
If
yeah.
this part is negative, the multiplication will cancel it off, but you have not reversed the sign, right?
Mm-hmm.
Do you understand what I'm saying?
Yeah, I understood.
So you can never multiply or divide in an inequality unless you are multiplying and dividing by a known constant. If I had multiplied by 2 or divided by 2, that's fine because I know 2 is positive. If
Yeah.
I had multiplied by minus 1 or minus 1, I know it is negative, so I will reverse the sign.
Mm-hmm.
So in this question, you cannot multiply. You have to bring everything to one side. If you cannot
Okay.
multiply, all you have to do is bring it to the one side, right?
Yeah.
You will say x plus 3 plus 1 by x plus 3, and you will say minus 2 divided by this is greater than equal to 0, right?
Yeah. Mm-hmm.
Then simplifying this inequality, the top part you have to simplify. You can simplify it by just simply adding it. There will be a by x plus 3 there.
Mm-hmm.
So x plus 3 comes in the denominator. You get x plus 3 whole square plus 1 minus 2 times x plus 3, right?
Yeah.
This is just the numerator right now that we are writing. So this becomes x squared plus 6x plus 9 plus 1 minus 2x minus 6 by x plus 3.
Yeah.
So the top part becomes x squared plus 4x is 10 minus 6 plus 4 by x plus 3, right?
Mm-hmm. Yeah.
So it is clear that this top part is x plus 2 whole square,
Yeah.
right?
Correct.
So the whole numerator part has been simplified to be this, right?
Uh-huh.
So my overall inequality is now x plus 2 whole square divided by x plus 3, x minus 3, x plus 2, right?
Yes.
Now I will apply wavy curve, and I will keep in mind that the numerator has a square. So actually you don't need to worry about the square part.
Yeah.
Why? Because we know the sign of the square part, right?
Yeah, it'll be positive.
So numerator is always positive. So that is not a concern for us. So when I do wavy curve, I will only do the bottom stuff, three of them.
Mm-hmm.
It will be -3, -2, and +3, right?
Yeah.
And also realize that you can never be equal to any of this. That's why I'm putting a circle around them, because you cannot be equal to -3 or 3 or -2, because it will make denominator 0,
Yeah.
right?
Yeah.
Denominator cannot be 0, and now we will do wavy curve. So we can see that above 3 everything is positive. So this side is completely positive, and between -2 and 3, x -3 will be negative, but the other two are positive, right?
Yeah.
So the overall product is negative. Between -3 and -2, two of them will be negative. Which ones? X plus 2 and x -3, right?
Mm-hmm.
Between -3 and -2, two of them are negative, one of them is positive. So overall thing becomes positive.
Yeah.
And below -3, all three are negative. So overall thing is negative, right?
Mm-hmm. Yeah.
So the expression here becomes positive in two places, where x is between -3 and -2 and x is greater than 3, right?
Yeah.
Also, the numerator, you could be, numerator is anyway positive, so this is my solution then, right?
Mm-hmm.
See, numerator can never be 0, because if you put x is equal to -2, the denominator vanishes, right?
Yeah.
X is equal to -2 is not included because it is present in the denominator also, right?
Yeah.
So therefore, what we are getting finally is this range.
Yes.
So that's how you do it. Keep in mind this thing, you cannot multiply by unknown sign stuff, right?
Yeah. Okay.
If you cannot multiply, all you have to do is bring it to one side and add and subtract. That is okay. But
Okay.
multiplication division is not okay.
Okay.
Okay. 15.3, have you seen?
Yeah, I saw 15.3.
What is taught there in that section?
The trivial inequality part of like how x squared is always going to be greater than 0 and stuff.
So what are they? You're using that to do what? To show some inequalities, right?
Yeah, like how the a squared plus b squared over 2 is greater than or equal to a times b.
Right. So, for example, if you look at the exercise there, 15.3.2, right? So,
Uh,
15.3.2. Let's see the first part of it. It says, if x and y are real numbers such that x squared plus y squared is 0, x and y are real numbers such that x squared plus y squared is equal to 0. What is x and y, right?
yeah.
So what is the logic? How do you do this?
Well, because it has to be real numbers, x squared should equal negative y squared, but the only way that's possible if x and y is 0.
But you're missing the key point that you're supposed to learn from this section. The main thing here is that according to the inequality, we know x square is greater than equal to 0, right?
Yeah.
That is true for any real x.
Mm-hmm.
The only way x square could be negative if x was not real.
Yeah.
Similarly, y square is greater than equal to 0, right?
Yeah.
Because there is a real y. So the addition of them, x square plus y square, will always be greater than or equal to 0, right?
Yeah.
But in the problem, what are they saying? It is equal to 0. The only way it can be equal to 0 is if both are 0.
Yeah.
Because they are positive, you cannot add two positive things and make it equal to 0 unless both the things are 0, right?
Yeah.
So that is how they're using the inequality. They're using the fact that each of them has to be greater than equal to 0. And since they are saying that the sum is 0, then both have to be 0 by force.
Mm-hmm. Yeah.
Part B.
Part B. Yeah. Hmm? Oh, for part B, I got that A is equal to -3, B is equal to 7, and C is equal to -3. So if you add that all up, it's 1.
Again, the idea is that the squares are adding up to 0. The only way squares can add up to 0 is if individually each of them is 0.
Yeah.
So therefore you get A is -3, B is equal to 7, and C is equal to A, which is -3. So now you
Mm-hmm.
can know the values of A, B, C, and adding it, it comes 1.
Mm-hmm. Yeah.
The next part is a very important idea, 15.3.3,
Yeah.
which is about AMGM. So
Uh,
if you have two positive quantities, two positive numbers, positive real numbers, x and y, the arithmetic mean of them is known as x plus y by 2. That
mm-hmm.
is called the arithmetic mean of these two positive real numbers. And the geometric mean of these two numbers is known as root over xy. Now, the inequality says that always am is greater than equal to gm.
Mm-hmm.
For any two positive numbers x and y, am is greater than equal to gm always. So you should have x plus y by 2 is greater than equal to root xy.
Yeah.
And the only way they can be equal, am is equal to gm, will happen if the two numbers are equal.
Yeah.
If you see the two numbers, if they are equal, the am would have been x and the gm would also have been x,
Mm-hmm.
right?
Yes.
So equality happens when the two numbers are equal, and otherwise, if any other case, am is greater than gm. What you have to do is prove this.
Mm-hmm.
How do you prove this am greater than equal to gm?
So I multiplied the entire thing by 2 to get x plus y is greater than 2 times root xy. And then I squared the entire thing to get x plus y whole square is greater than 4xy. So then if you expand x plus y whole square and take the 4xy to the other side, you get x squared minus 2xy plus y squared is greater than 0, which is then x minus y whole square is greater than 0, and the square is always greater than 0. So that means this must be true.
Right? The thing is, if you are using the inequality like this, you have to realize that you have to reverse all your steps, right? You understand what I mean?
Oh, yeah, yeah, I know. Like work
Because
backwards.
you have to work backwards, because technically what has happened is you have used the inequality, right?
Mm-hmm.
So at the end, you should say that if you start off from the end point, you can go work backwards and prove that this is correct, right?
Yeah.
Because we can't assume that it is correct and then say that yes, this is correct, right?
Mm-hmm.
Do you understand what I mean?
Yeah, I understand.
So right now I will say x plus y minus 2 root over xy is greater than equal to 0. You don't actually have to square it for showing it, because we can work with this itself. We can say that, okay, I will say x is root x whole square and y is root y whole square minus 2 times root x times root y, right?
Mm-hmm.
So this is clearly root x minus root y whole square.
Yeah.
This left hand side is that, and since this is greater than equal to 0, now when I write a proof, how will I write it? I will start from here. I will say that this clearly square is positive, so this part is positive, right?
Mm-hmm.
This inequality is true, and then I will expand it, which implies that root x square plus root y square minus 2 root xy is greater than equal to 0. And then I will say, okay, then x plus y is greater than equal to 2 root xy. And that implies x plus y by 2 is greater than equal to root xy.
Yeah.
So even though in order to understand the proof, you work like this, but while writing the proof, you have to start from here, right?
Yeah.
Because this is a true statement, this is a correct inequality, and from there we are figuring out and we are showing that the original thing that we wanted to prove is also correct.
Mm-hmm.
Do you understand?
Yeah, I understood.
Okay. Then this section is done, and then we have 15.4, which is quadratic optimization. Have you read anything there?
No, not yet.
Okay, so we'll do the section here. So let's look at some of the problems. 15.11. Okay, 15.11 part A. Question is saying, what is the uppermost point on the graph of this? Y is equal to minus x square plus 5x minus 7. Minus x square plus 5x minus 7. What is the uppermost point on the graph, right?
Mm-hmm.
So what kind of a graph is going to happen here when this is my quadratic?
A downward facing graph?
Because the first coefficient is negative, right?
Yeah.
So the graph should be somewhat like this, right? It should
Mm-hmm.
not be an upward facing graph, correct?
No.
Also, discriminant I will check first. So I'll say 25 minus 4 into minus 1 into minus 7, right? And
Yeah.
I'm getting, notice that it is 25 minus 28, right?
Yeah.
It is negative 3. Discriminant is negative. That means this graph is incorrect. Because this graph tells me there are two roots, right?
Mm-hmm.
You understand discriminant is negative. That means there cannot be roots, right?
Yeah.
So the graph should be like this, right?
Mm-hmm.
If a downward facing quadratic does not have roots, it should be like this, correct?
Correct.
So now my job is to find the uppermost point of the graph, which means obviously I have to find this point, right?
Mm-hmm.
This is the highest point of the graph, right?
Mm-hmm. Yeah.
What is this point called in the parabola?
The vertex?
Right. So we have to find the vertex of the parabola and what is the value of the y value here. You have to find where is the x coming where the vertex is, and also the height of that or y value for that graph. Okay.
Yeah.
So anytime you have a quadratic and you have to find the vertex, the best way is to do a completing the squares method. Okay.
Mm-hmm.
So For example, if you had y is equal to ax squared plus bx plus c, if you recall, we can write it as a common and then x minus b by 2a whole square plus 4ac minus b squared by 4a squared, right?
Yep.
This is the same thing as the original graph, but what we have done is completed the square here, right?
Correct.
Now, from this data, from this version of the equation, you can easily say that when x is equal to b by 2a, this portion vanishes and the y value will be minimum, right?
Yeah.
Because we know that this is a square, so this part is greater than or equal to 0, right?
Correct.
If x was not equal to b by 2a, the bracket will definitely, the whole bracket will definitely be bigger than what it would be if x is equal to b by 2a. Right?
Oh, it'll just be 4ac minus b squared over 4a squared.
What I'm saying is, how can you minimize the value of y? Think about that.
Oh,
You
by
can,
making,
right, when x is b by 2a, you can minimize it, no?
yeah.
Because if you don't put x is equal to b by 2a, then for sure this quadratic will give us a positive value rate.
Yes.
This much will give us positive, this much I don't know what will happen to this. That is a constant.
Uh-huh.
Do you understand what I'm saying?
Yeah.
So some constant number here plus some square, if I want to make it as low as possible, I need to make the square 0.
Yes.
So vertex is usually the minimum point of a quadratic if the quadratic was upward facing, right?
Uh-huh.
If the quadratic graph was like this, the vertex is the lowest point, right?
Yeah.
And we can see from this that the lowest point will happen at x is equal to b by 2a, right?
Mm-hmm.
Are you understanding what I'm saying?
Yeah, I understood.
So similarly, if my a was negative, then the graph has been reversed. Now vertex is not a point of lowest point, it is the highest point.
Mm-hmm.
So again, vertex, however, should happen at x is equal to b by 2a, right?
Yeah.
So that is still valid, that vertex will come at x is equal to b by 2a. Now what we will do here is we will confirm that that happens. So in order to confirm that, I will say y is equal to minus common. I can write it as x squared minus 5x plus 7, right?
Yeah.
And now I'll complete the square. X squared minus 2 times 5 by 2x plus 25 by 4 plus 7 minus 25 by 4. This is my stuff inside and there is a minus sign outside, right?
Yeah. Yeah.
This first three terms are x minus 5 by 2 whole square. And this term is 28 by 4 minus 25 by 4. So plus 3 by 4, right?
Mm-hmm.
This is what is coming. Y is equal to minus of this stuff.
Yeah.
So notice that this part will be minimum if x is equal to 5 by 2, right?
Yeah.
Suppose x was not 5 by 2. You should realize that the overall thing is more if x is not 5 by 2 and y is equal to negative, so it will be lower, right?
Yeah.
So the maximum happens when x is equal to 5 by 2.
Mm-hmm.
Are you understanding what I'm saying?
Yeah, I understood.
So notice that that is the b by 2a of this graph. Like if you take
Yeah.
by 2a is actually 5 by 2 into minus 1 minus 5 by 2. So you have to take the negative sign outside and do b by 2 on this part, right?
Yeah.
Something is here. Okay, don't worry about that. Complete the square and you will get the answer, right?
Mm-hmm.
Don't worry about the actually doing the v by 2 stuff, because I think because of the negative sign it is slightly different.
Okay.
You have to complete the square and realize what is happening. So at x is equal to 5 by 2, let's check the value of y. Y is coming out to be minus 25 by 4 plus 25 by 2 minus 7. So this is becoming minus 25 by 4 plus 25 by 2 minus 14 by 2. So plus 11 by 2, that is plus 22 by 4. So minus 3 by 4. Y value is coming as minus 3 by 4 at this level, at x is equal to 5 by 2, right?
Yeah.
You can check any other value of x. Always the y value will be less than minus 3 by 4. Right now I'm getting this point as 5 by 2 comma minus 3 by 4, right?
Yep.
Check any other value. Let's check x is equal to 0. If x is equal to 0, y is minus 7. Notice that minus 7 is lower than minus 3 by 4.
Yeah.
Check x is equal to 1. Minus 1 plus 5 minus 7. That is basically minus 3.
Yep.
So all other points that you will find it is lower than this. That means what we have gotten is correct, and it happens at the vertex of the parabola, and you find the vertex by completing the square.
Yes.
So that is your part A, and again part B is also asking the similar thing. What is the largest possible value of this? Okay, we have already figured it out. So let's look at question number 15.13. 15.13. So here he says find the largest possible value of this if a is a real number. Largest possible value
Yeah.
of minus 3a square minus 36a plus 2. Okay. So again notice that it's a quadratic that is downward facing again.
Yes.
The discriminant of the quadratic is 36 square minus 4 into minus 3, so plus 12 into 224. So clearly discriminant is positive, right?
Mm-hmm.
If the discriminant is positive, the graph should be cutting the x-axis and going like this, but downward facing, right?
Yeah.
Okay, so it has roots and it is going to be above the x-axis sometimes. And we have to find the largest possible value of this. We have to find the height of this parabola, the largest height. Okay?
Yeah.
Do you understand what I'm saying?
Yeah.
So at what value is it coming? It will happen at the vertex. So I'll do the same thing. I have to find the vertex and I have to find the maximum value, right?
Mm-hmm.
So let's say y is equal to minus 3a square minus 36a plus 2. I will say y is equal to, I'll take minus 3 common. It will be a square plus 12a minus 2 by 3, right?
Yeah.
And now I have to do completing the squares inside to figure out the vertex. So I'll say it is a square plus 12a plus 36 minus 36 minus 2 by 3,
Mm-hmm.
right?
Yeah.
This part becomes a plus 6 whole square, and here you get a minus 108 minus 2, so minus 110 by 3, right?
Yeah.
So notice that the graph, obviously now this part will be the lowest possible value if a plus 6 whole square is 0, right?
Yes.
Correct? Otherwise it will be higher than that.
Mm-hmm.
Do you understand that if the thing inside the bracket is larger, the y value will be lower because of the multiplication with -3?
Yeah.
So you want to make the thing inside the bracket as low as possible, so that when you multiply with -3, it will be as high as possible, right?
Yes.
So the thing inside the bracket, if you want to make as low as possible, that will happen only when the square part is 0, right?
Yeah.
So if a is equal to -6, the whole thing inside the bracket becomes minus 110 by 3, right? And y becomes -3 times this, so it is just simply 110, right?
Yeah.
So we can just say the answer, the highest possible value of this function is 110, and it happens when a is equal to -6. Do you understand what is happening?
Yeah, I understood.
You can now check any other value of a. You will never get a value bigger than 110. You
Yeah.
can check whatever value you can try. Let's try a is equal to -5. You will get -3 into 25 plus 180 plus 2. You're getting 182 minus 75. That is 107, which is still less than 110. Do you realize what we have done?
Yeah.
So we have gotten it by looking at the graph and finding the vertex of the parabola. Once you have done that, it will always be correct. So you can figure out the largest and lowest values of the parabola, right?
Okay. Yeah.
Okay, so then tell me how to do, for example, 15.15. Let's do 15.15, part A.
Uh, 15.1. Okay, I see it.
First question is asking is, what is the smallest value of this expression? When does it happen?
So that'll happen at the vertex because it's an upward facing graph.
Find the vertex and find the smallest value.
Yeah, okay. I got that the smallest value is -4, and that happens when x is equal to 4.
So you will complete the square, you will get x minus 4 whole square minus 4, right?
Yeah.
And obviously, smallest value will happen when x is equal to 4 and the negative value is -4. That's correct. Let's go to part B then.
Mhm.
Find the roots of this equation.
Okay.
Roots of the same equation, x square minus 8x plus 12 equal to 0.
I got 6 and 2 as the roots.
Great. So 6 and 2 are the roots. And notice one thing, he's asking you in part C, how is the value of x found in part A related to the values of x found in part B?
Oh, if you subtract the roots, that equals the x.
That is one thing. Another thing you can say is that obviously the graph of the quadratic is something like this, right?
Oh yeah, it's straight in the middle of the
Right.
roots.
So the vertex is always going to be the midpoint between the roots, right?
Yeah.
The vertex is the line that is symmetrically dividing the parabola. It is like a mirror line for the parabola, right?
Mm-hmm.
So this half of the curve looks exactly same as this half, and vertex is always going to be the midpoint of the roots, right?
Yeah.
So you can say that x value of the vertex you can find by saying alpha plus beta by 2, right?
Yep.
If the roots are alpha and beta, the vertex should be at alpha plus beta by 2, right?
Mm-hmm.
Can you see that it is coming here 6 plus 2 by 2?
Yeah.
So if a quadratic equation has real roots, if you can check the discriminant of that quadratic, and if it has real roots, then you can find, and even if it has imaginary roots actually, even if it had imaginary roots, alpha plus beta by 2 will be the place where the vertex will be, right?
Mm-hmm.
Do you understand what I'm saying?
Yeah.
And by Vieta's relations, we know alpha plus beta is minus b by a, right?
Yes.
What is alpha plus beta by 2, right?
Minus b by 2a. Yeah.
So the vertex will be at minus b by 2a, right?
Mm-hmm.
That is the point where the vertex is.
Yeah.
Are you understanding?
Yeah, I understood.
So that is what he wants you to get from here. And part D, if you read, he says, suppose the quadratic ax square plus bx plus c, where a, b, c are constants and a is greater than 0, has real roots r and s. Show that the value of x that minimizes the quadratic is the average of r and s, right?
Mm-hmm.
So in general, if my quadratic was like this, the roots are r and s. We know r plus s is equal to minus b by a, right?
Yeah.
And now I will simplify this equation and make it a perfect square and find the vertex. To do that, I have to take a common. I get x square plus b by a x plus c by a. And now I have to write this as x square plus b by 2a times 2 times x plus b square by 4a square plus c by a minus b square by 4a square, whole thing multiplied by a, right?
Yep.
So y is equal to a, if you see completing the square here, is x plus b by 2a whole square, right?
Mm-hmm.
Plus you are getting 4ac minus b square by 4a square, correct? Are you understanding this is coming?
Yeah, I understand.
So if a is positive, the minimum value will happen when x plus b by 2a is 0, where x is minus b by 2a. That is your vertex, right?
Yeah.
At that vertex, this part vanishes and the answer will be 4ac minus b square by 4a. Correct?
Correct.
And notice that minus b by 2a is simply r plus s by 2. Right?
Yeah.
So the location of the vertex, which was x is equal to minus b by 2, is the same as the average of the roots, right? R plus s by 2.
Yeah.
So even looking at the quadratic, since you know what is r plus s is minus b by 2 minus b by a by Vieta's relations, now we can connect it and find the vertex really easily, right?
Mm-hmm.
We don't have to do the completing the square process at all. We just have to say minus b by 2a. Do you understand what I'm saying?
Yeah, I understood.
Can avoid doing the whole completing the square process, because you can say that the vertex will be the midpoint of the roots. So roots are r plus s will be minus b by a. So vertex is at x is equal to minus b by a by 2.
Yeah.
Okay, so that is what he wants you to get from there. Then you need to now check the remaining questions in this section and do the exercise. I don't think there's any other section in the chapter. Hopefully not. Let's see. Right, there is nothing else in the chapter. You just have to do the 15.4.124 and then the exercise at the end of the chapters. Right.
Okay.
So review problems and challenge problems. There are quite a few problems. You have to go till 15.46 actually from 20 from 18 to 46. Okay. So many of them will be easy because we have already done it. But if you are doing all the problems, you will find some challenging ones also. So make sure
Okay.
that you try it properly, all of it.
Yeah.
And we have covered basically everything that is required. The main things we learned in the chapter were the wavy curve method for doing normal inequalities. Then we saw in the previous section, we saw the AMGM inequality, right?
Yeah.
X plus y by 2 is greater than equal to root xy. And in this section, what we have seen is how to get the maximum or minimum value of a quadratic graph. It will always be
Mhm.
at the vertex, and the vertex value can be gotten by the completing the square method or by realizing that the vertex will be having the x value at the midpoint of the roots, which is going to be minus b by 2a, right?
Mhm. Yeah.
So the homework is the 4 problems in 15 point, so basically 15.4.1 through 15.4.4, and then review plus challenge exercises. That is from 15.18 to 46. Obviously, I don't expect you to do all of it by the next class, but try to do as much as possible.
Okay.
So we'll discuss questions in the next class and try and close the chapter as much as possible.
Yeah.
Okay, try it out, see how much you can do. We'll
Okay.
talk in the next class.
All right. Thank you. Bye.